So today we are going to talk about the first derivative test. And tomorrow we're going to talk about the second derivative test. It is not like a test for y'all. It is a test of numbers. So it's a process. The first derivative test gives us a way to find the extrema, which are the max and the mins. So we're going to do the exact same thing we did yesterday. We're going to find our critical numbers by setting our derivative equal to 0 and undefined. We're going to create a number line. We're going to put all of that stuff on the number line. And we're going to find the increasing and the decreasing intervals. And so a minimum is going to happen when f prime goes positive. Oh, wait. A minimum negative, sorry. When f prime goes negative to positive. A maximum is going to occur when f prime goes positive to negative. And when you look at your number line, it is going to make sense because if your derivative is negative, you are decreasing. And if your derivative is positive, you are increasing. And so if you go from decreasing to increasing, you would have a minimum, and then vice versa. If your derivative is positive, you're increasing, and when it's negative, you're decreasing. And so if you go from increasing to decreasing, that's where you have a maximum. Now, h of c, if h of c does not exist, then x equals c cannot be an extrema, and so that's going to happen for vertical asymptotes. So kind of just watch out for those. And when do you get vertical asymptotes? Like what kind of functions? Fractions. So if you have fractions, just kind of be mindful of what the vertical asymptote is. All right. So let's do an example. It says find the location of the relative extrema of 1/2 x minus sine x on the interval from 0 to 2 pi. So that interval 0 to 2 pi is just talking about one rotation of my circle. So I'm going to first find the critical points by taking the derivative. So the derivative of 1/2 x is 1/2, and the derivative of negative sine is going to be negative cosine. And what do I do with the derivative? Yes. So I'm going to minus 1/2. Divide by negative 1, and so you get cosine equals 1/2. So yes, this is a unit circle question, so I'm going to go to my unit circle. I do have them printed somewhere. I will look for them.
So pi over 3 and then one like on the opposite.
Mm-hmm. So pi over 3 is 1, and then this one right down over here. So I'm probably going to have to count. So 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, 9, 6, 10 pi over 6, which reduces to 5 pi over 3. And it's just one rotation of the circle, and so we're not going to keep going. Those are my critical numbers. So then I'm going to take my critical numbers, and I'm going to put them on my number line, pi over 3 and 5 pi over 3. And I'm also going to make note that my number line actually isn't going to go to infinity forever because it's stopping at 0 and it's stopping at 2 pi. So just kind of know that if you're talking about your unit circle, a lot of times you'll have stopping points. It won't go forever. All right, so I got to figure out what is happening on these intervals. So I'm going to plug my stuff in to the derivative. All right, so my derivative, which is this guy right here, the guy that you had set equal to 0. And if I'm talking about the x values from 0 to pi over 3, all right, are these x values going to be bigger than 1/2 or less than 1/2?
Bigger.
Bigger, because 1/2 is like right here, right? All right, this is 1/2. So all of the numbers from 0 to pi over 3, they're going to be bigger. So 1/2 minus a number bigger than 1/2 is going to be negative. All right, from pi over 3 all the way down to 5 pi over 3, they're either going to be smaller than 1/2 or they'll be negative, and the double negative will make this positive. Does that make sense? So then this would be positive. And then from 5 pi over 3 to 2 pi, this little section here, same situation. That's going to be negative, so you'll be decreasing. The x values are positive here. The y values are negative, but since we're talking about cosine. All right, so I have my number line just like what we did yesterday. So from here, what we're going to do is say something about the extrema, which are the max and the mins. So where is there a maximum? 5 pi over 3. And where is their minimum? Pi over 3. And that's first derivative test. All right, go to 23. All right, so we are going to take the derivative. So f prime of x is going to be 2/3. Inside stays the same. What's my new exponent going to be? Negative 1/3. And then times by 2x. All right, so I'm going to put that into a fraction. So the x squared minus 4 to the 1/3 is going to go on the bottom with the 3. And then on top, 2 times 2x is going to be 4x. All right, so the 3's on bottom. This x squared minus 4 is going to go to the bottom because that's a negative exponent, and then the 2 times the 2x, that's going to go on top. All right, so from my derivative, and it's one giant fraction, you are going to set the top equal to 0, which is going to give you what critical number? 0. And we're going to set the bottom equal to 0. Now, when I set the bottom equal to 0, do I care about the 3? Do I care about the 1/3? No. All I care about is this guy right here, because when you divide by 3, you still get 0. When you raise it to the 3rd power, you still get 0. So x squared minus 4 equals 0. What are my critical points going to be? Plus or minus 2. All right. So on my number line, I've got -2, 0, and 2. All right, so we're going to plug in some test numbers. So like -3, a number on the left side of -2. What's the top going to be? Negative. And then -3 squared minus 4 is going to be? Positive. So a negative divided by positive is going to be? Negative. All right, and then you're going to do -1. And so you get a negative over a negative, which is? And then you do +1, which is a positive over a negative. And then you do 3, which is positive over positive, which is positive. A lot of times they alternate, but not always, so you do have to check. Generally, if something doesn't alternate, I double check my work. All right, if it's alternating, I'm like, yeah, it's probably right. I don't know if that's a good strategy or not, but it's the one I use. All right, so from my number line, I can figure out where the extrema is. So where are my maximums? 0. And where are the mins? -2 and 2. All right, last one of these guys. I do want to do a fraction because I want to show you what I mean when I'm talking about the vertical asymptotes. All right, so on this one, I'm like, okay, there's a fraction. That's great. I'm just going to make a note. Where is your vertical asymptote at? At 0. All right, so I'm just going to make a little note to myself that there is a vertical asymptote at 0. It is going to end up being a critical number, but it can't be an extrema because it's an asymptote. All right, so started off the same way. We're going to take the derivative. What rule do I have to use? Quotient rule. All right, so low, what's the derivative of the high? 4x to the third minus the high function. What's the derivative of the low? 2x all over low squared. So it's going to be x to the what? X to the fourth. All right, so we can simplify this a little bit. What does every single term have? An x. So I'm going to take an x out. So that's going to go down to a 3. That's going to go down to just an x. And then this x here is going to go away. So x times 4x cubed is going to be 4x4 minus 2 times x4 minus 2. And on the bottom, x3. Which is just 2x4 minus 2 over x3. And I can even take this a little farther and take a 2 out and go x4 minus 1. Which will help me with my critical numbers.
Is there like a difference of like folders?
It's still a difference of squares. It's just what times what would give you x to the fourth. X squared. So you would go x squared plus 1, x squared minus 1. But you can also think about just add 4 and then fourth root it. So your critical numbers on top are still going to be plus minus 1. Because the fourth root of 1 is still just 1. The 2 is GCF. It doesn't have an x, so it's not going to give you any critical numbers. And then the bottom critical number is going to be 0. Okay, so on my number line, I'm going to put -1, 0, 1. We're going to plug this into f prime, and it's going to tell me stuff about f. All right, so when I plug in -2 into here, I'm going to get a positive number on top, but a negative number on bottom because the cubes will keep the sign. Does that make sense? So it's going to go negative, so it'll decrease. And then when you plug in like 0.5, you'll get negative, so positive. And then negative, this one's going to alternate, and then positive. Does that make sense so far? Okay, so where would your max be? Right, because the 0 is a VA, so it's actually not a maximum, even though when you look at your sign chart, it is. So kind of what's happening is this is actually just going like up forever. It's not actually curving because it's undefined there. So you don't have a maximum.
Yikes.
Who's that? Is that you?
It's the iPad. That's the iPad.
Oh, it's my timer. Oh, it's my timer. I'm almost done. You've said it for 13 minutes, didn't you?
No.
Okay.
You said we said
I said 14.
Well, sure, I mean, it's not.
Well, I'm really close to being done.
Use it.
Your minimums are at -1 and 1. All right, so the last part here, because a lot of times on the AP test, they're not going to give you functions, they're going to give you graphs. All right, and they're going to give you graphs of the derivative. And they're going to ask you stuff about the original f. So part A says identify when the interval is increasing and decreasing. So think about what that relationship is. What is special about f prime when your function's increasing? It's positive. So right, f prime is positive. What's special about it when it's decreasing? It's negative. And that way in your brain, you have something that you're looking for. Because what everybody does is they come over to this graph, and in their head, they're thinking increasing and decreasing, and they do the increasing, decreasing intervals of this graph. But that's not what I want. I want increasing and decreasing of f, and this is f prime. Does that make sense? So you got to think about what that relationship is. So really on this graph, I'm looking for when is f prime positive? From -4 to 2. And 6 to infinity. And then when is f prime negative for the decreasing? -infinity to -4, and then 2 to 6.
Isn't it more 5.5 to infinity? Or
here's where you're crossing.
Oh, that's.
It's kind of hard to see with the.
That is such.
They're like a little bolder.
Oh, that's the one?
Yeah. I don't know why the numbers are.
Oh, the whole line down?
Yeah, I don't know. I don't know why.
Yeah, one side goes to 6 and the other goes to 8. So
Yeah.
This is really.
Okay. So increasing and decreasing is think about, positive and negative. And then for maximums and minimums, and if it helps you to draw your number line, you can, -4 to 6. So you go increasing, decreasing, starts decreasing. Decreasing, increasing, decreasing, increasing. So if it helps you to draw your number line at the points where you stop at -4 to 6, your critical numbers when it hits 0. And then you start negative, so you decrease, increase, decrease, increase. And I think the number line kind of visually helps you see your max and your mins. So your minimums are going to be at -4 and 6. And your maximums are going to be, it's going to be at 2. So minimums have to go on the graph negative to positive because minimums go decreasing to increasing. So your derivative goes negative to positive for minimums. Maximums go positive to negative. Does that make sense when you're looking at your graph? Okay, so on this one, where are you increasing?
Oh.
We're going to say this is, we're going to say that's -4. We're going to say this guy here is 2. We're going to say this guy here is 4. And we're going to say this guy here is 8. Okay, so -infinity to -4. And then where else? 8 to infinity. All right, and then decreasing would be -4 to 2 and 4 to 8. Okay, so now I want to know specifically at these numbers which one's a max and a min. So at -4, is that going to be a max or a min? If you're going from positive to negative. Max. What about at 2? Min. Negative to positive is min. What about a 4? Max. And then at 8?
So you kind of have to look at it like a sideways, maybe like when you turn your head.
If that works in your brain, sure. You might have to explain that to me. I don't know.
Like if you like turn your head and you like fold it a little bit, you can make like out of it.